Hello to everybody, good afternoon. I want to thank Monse and the rest of organizers for inviting. I'm going to talk about invasive species in fresh waters, mainly but not only about fish, and mainly but not only in the Iberian Peninsula. Most of the works that are going to be part of the speech are made in collaboration with Virgilio Hermoso, which is this jumping guy, and then there are also a few other co-authors that are listed here. Well, first, I will make just a short introduction on the native fauna of the Iberian Peninsula, just very, very short. There are some 50 native species, something like that. Within that number, there are some migratory species included. But within that 51 species, that is currently increasing. There are more new species being described, but 2 out of 3 of those species are cyprinids, and 80% or more than 80% are endemic to the Iberian Peninsula. Not only endemic to the Iberian Peninsula, but they are also mainly endemic to one or a reduced number of basins. Just a single characteristic that I wanted to highlight is that there are very few native fish predators, or piscivorous fishes. I mean, naturally, in the regional communities, only the eel, that was once widespread, was a piscivorous fish, and then we have the trout, but is restricted to high altitude. Now the eel has totally collapsed. It's nothing like there used to be, and the trout is only widespread in northern Spain with cooler weather conditions. Regarding conservation status, looking at all species in the Iberian Peninsula, we have almost 60% are globally threatened, that is vulnerable, endangered, or critical endangered. Globally, these are global assessments. But if the thing is that we have some widespread globally species that are highly threatened here, but not globally, just as sticklebacks or sea lampreys or brown trout. They are threatened in Spain, but not globally, then they are not assessed as threatened by USCN. But if we consider only endemic species, we have 70% that are threatened. That is one of the highest proportion of threatened species of any organism anywhere in the world. Regarding the environmental conditions, most of the Iberian Peninsula have a temperate climate, which is in which we have very hot summers and very dry summers, and then the summer drought is a very predictable event. You can be sure that it won't rain during summer, but then autumn, winter, and spring rains are very unpredictable. So you have some years with very high rains and some very dry years. This is a series of pictures from a stream in the Guadiana Basin. You can see how from April up to October the habitat is shrinking. There is during summers, most of streams are reduced to isolated pools. So you can imagine that a fish that evolved in such a changing conditions must be able to cope with very large habitat variation. If we go back to the beginning and to the end, we see that, and we are missing the flooding events that are very important, because the one Felipe that took the photo was not there when the peak flood came, but you can imagine 10 times as much water as in here, something like that. Now, going to introduce species, we have some 32 species introduced to the Iberian Peninsula, and at least 25 of them are definitely established, have self-sustained populations in the wild. If we go a little bit to the history, the first introductions come from the 16th century. We will go a little bit with that later, but they are probably related to the arrival to Spain of the Habsburg monarchs. This is Emperor Charles, which is the grandson of the Catholic kings. He was born in Belgium, so he came to Spain for the first time when he was almost 15, and he was very keen on fishing and so on, and he probably, or his court, probably were responsible of taking tench and probably carp also into Spain. He was known to have tench in the monastery where he retired a few years before dying. Then in the late 19th century, some trout for sport fishing were introduced, as well as the European lineages of trout were also beginning to be introduced in that time. Then there is a special case in Spain, which is Lake Banyolas, which is in Girona. There is a lot of papers on that lake, but the thing is that in the early 20th century, there was a person there called Dardet that started releasing fish in the lake, and there was something called the fish party, where a lot of people from the village went to the lake and released the fish. They put pumpkin seed and other American species, but also salmon and also trout and so on into the lake. Then in the 50s, the government started putting into fresh water the large predators for sport fishing. They put the pike, they put the largemouth bass, and then this trend followed with illegal introductions like that of the Welsh catfish and the pike perch that are spreading, both of them are spreading quite quickly within the Iberian Peninsula. And the more recent introductions are often related to aquarium trade and so on. They are small fish held by particulars in aquariums, and also small fish used as live bait that are related to those people fishing those fish. They take the bucket with the live fish and release them in the water. And now we have all those species introduced, and the thing is that once the species are introduced and they are established, all of them spread. If you represent the time a species has been present in the Iberian Peninsula against any measure of extent, you get a positive relationship. That means that the more the time they are here, the more the space they occupy. So I would say now, but this is almost or something more than 10 years old, that the situation is worse now, but at that time, the average in the Iberian Peninsula was that each basin had more non-native species than native ones. And it is quite a common feature of all Mediterranean areas. This is a global assessment of freshwater fish introductions, and all areas with Mediterranean climate are like hotspots of fish introductions. Something about the routes, invasion routes, where do they come from? There was this study by Emily Garcia that analyzed the known introduction events, and it was quite clear that fish came into Spain from France and then went into Portugal from Spain. We share the river basin, so the Spain-Portugal connection is a natural one. Almost nobody has to take the fish to Portugal, they go alone. But they have to take the fish into Spain from somewhere, and they mainly take them from France. If we analyze the similarity of the fish communities using only non-native species, and we got that the northeastern basins were the more related to French basins, so that apparently signal an invasion route through the Catalan basins and through the Ebro basin. And it was represented by the example of the pike perch. It was not native to some French basins, but it was spread all over France in the end of the 19th century. It was introduced into the Muga basin, very near the border, in the 70s. Then in 1990, it was sit in the Ebro basin. During that decade, Tagus, Douro, and Júcar, and then we have it almost all over. I'm sure there is a pike perch in the Guadalquivir, but it has not been reported yet, but I'm pretty sure they can be found here. Now, something about impacts. I'm going to go through some different studies. We made a study using the whole Mediterranean data from the whole Mediterranean region that comes from an assessment of UCN, but we excluded the southern Mediterranean, Northern Africa, because the data quality is quite worse in comparison with other areas. We converted the distribution polygons into 10 kilometers squares. That's not very, that's quite wrong way of doing, but we got these fine maps, and then we tried to correct this incorrect behavior. But what we did is we knew the threats that affected each species. We know by the UICN assessment if one species was threatened or not by invasive, if it was threatened or not by pollution, threatened or not by reservoirs, at least by expert opinion. And we plotted that in a map. Then we did a multivariate analysis to create threat gradients. So we had the first gradient was a gradient separating areas where invasive species were an important threat from areas where agriculture and pollution were recorded as main threats. And the second gradient was related to reservoir and one strain and overfishing in the other. The thing is that the first gradient, the gradient that was related to the importance of invasive species as a threat, was highly related to the proportion of invasive species, both at the square level, but the square level is highly pseudo-replicated. But when we went at the significant hydrologic unit, which is the basin, we had also the same result. That we were pretty convinced that it was not because we were pseudo-replicating because of the high number of squares. And then we went to a single basin. We had a survey in the Guadiana Basin, which is very important in terms of richness. It has an endemic genus of fish there in the Guadiana. And we had some 180 sample points. And what we tried to test with this data is this framework proposed by Didham and other authors, where they wanted to, what they said is that the impact of invasive species should be proved, not only assumed, and they proposed that invasive species could be the driver of environmental change, they could be causing biodiversity loss, or they could be simply passengers, meaning that other causes cause biodiversity loss, and then invasive species replace native ones. Then there could be a combination of both processes. In our data, we use path analysis. We found support for the driver model and for the full model. There were some habitat variables related to a native fish richness, but the passenger model, that model in which invasive species are not the direct host, did not have any support. So our conclusion is that we have a clear, it's also correlative, but quite strong proof of the direct impact of invasive species there. Then we went to reservoirs. If we look here, if you look here, there is a relationship between invasive species and distance to reservoir. There are a lot of there was some information about the importance of reservoirs for invasive fish, and we studied reservoirs and rivers in the same basin. And we noticed that there were no differences in fish species richness between river sites and reservoir sites, but reservoirs had many more invasive species than rivers, and the other way around also. Using data from a lot of reservoirs all over Spain and Portugal, we made a similar approach using also path analysis, and found that there was a very clear negative effect of invasive fish within reservoirs on native species. That means that we didn't find, in part, or at least partially, we don't find native species within reservoirs because of the negative effect of invasive ones. Then in fact, it comes from the other paper, but the question would be, then which are the species that are lacking from reservoirs? And we had that analysis in which we related the sensitivity of a species to invasive fish within rivers. We had a species that never coexist with invasive species in rivers, and a species that occasionally or often coexist with them. And we compared that index with the frequency in which we found each fish species in a reservoir. And what we found is that species that are sensitive to invasive fish are never found in reservoirs, while those that are able to coexist with invasives are often found within them. So our reasoning is that most native species will be able to occupy reservoirs if invasive species were not there. And if you think about the series of photos of the shrinking stream, you can imagine that having a standard of running water is not a big difference for a fish that has evolved in such an unstable environment. They are able to occupy a huge variety of different environments. Is the invasive species taken there that are avoiding native to occupy the reservoirs? But the impact of reservoirs go beyond the mass of water stored behind the dam. If you see this paper in PNAS comparing flow regimes before damming and after damming, what they show is that the regimes are being homogenized. The flow regimes of the variability of flows are being homogenized by reservoirs. Reservoirs release water depending on human needs, and human needs are quite homogeneous. If you have to irrigate your field, you always need it more or less on the same time. So you break the natural variability and put a human-related variability on flow regimes, and that homogenization of flow regimes often lead to homogenization of faunas, because fish not having evolved in a system with a certain variability regime can be present there. We have the idea to work on the effect of flow alteration on invasive species present on streams, but that has not been evolved much up to the date. What we have is some data from southern Morocco that were taken just this year. Is an extreme Mediterranean environment where flow variability is huge and summer variability, summer flow is very, very low. And what we have, if we put a gradient of distance to reservoir, what we see is that non-native species are hardly ever found above reservoirs. Above reservoirs, regime is natural, there's no way of regulating it, so they have the huge floods and they have the very heavy drought. But below reservoirs, they just leave water during summer to have the people, irrigating the palm orchard and so on. And then below reservoirs, non-native species are able to establish. And something about the future, we made some predictions on which fish species could come in the future based on the assumption, not necessarily true, that the characteristics of future invaders would be similar to the species that has been already introduced. We use a lot of variables to construct this risk index, and I will only explain that we use that to find a list of species that we consider that it is highly probable that they become introduced in the Iberian Peninsula. And I'm taking it here because that's the list. It's not important, but one of the things is that there are a lot of tilapia species. These are warm water species that currently are not probably able to establish in the Iberian Peninsula. Maybe in the lower Andalusia they can because of the winter temperature, but they will, in the predictions, with the predictions of climate change, almost the whole Iberian Peninsula probably will fall within the tolerance range of at least some of these species, at least some Tilapia thili and Orechromisaurus for sure. And then after the future, we go to the past, to the deep past. Well, not the deep past. The deep past is the other session. We go to the historical reports to analyze or I wanted to highlight the importance of long-term studies in invasion biology, as illustrated by this study that we made on these three introduced species in Spain. There's, you probably might feel curious about the presence of Austropotamobius cryfish in here, which we call in Spanish the native cryfish, and which is an introduced species from Italy. And what we made was to collect past references on the presence of this species. We went to the 16th century to a very, very interesting source of information that is called the Relaciones de Felipe II. Felipe II, Philip II was the son of Emperor Charles, as we saw in a previous slide, and he ordered like a structured interview in villages that was made in 600 villages or something like that, asking about fauna, about wild fauna, about hunting animals, and about fish. That in fish included in that time of the word pescado in Spanish included shrimp, included terrapins, of course fish, but also otters, for example. And then we went to the geographic dictionaries in the 19th century, and that only to put the changes in the distribution of the locations where the species were found. Maybe we can go to the cryfish. Is quite interesting. In the lower right panel, there are two maps. The background is a distribution in the 60s, which is the peak distribution, and then came the massive decline of the species after the introduction of American cryfishes. And here is more or less the idealized patterns. This is we have in the y-axis we have range extent. We have the evolution of tench that became highly appreciated soon after the introduction. Is appreciated food in a lot of places in Spain. Then we have the carp that is very curious that didn't become an invasive fish until more than 300 years after its initial introduction. People in Spain didn't like carp. We still do not like carps. But at some time, we started liking fishing carp. And at some time, we started regulating rivers. So rivers probably became appropriate habitat for carps when they were not in the past. So there were a time lag and the species becoming invasive of more than 300 years. And then we had the cryfish introduced somewhere in the 18th century that became very highly appreciated animal. Everybody loved cryfish, they took it everywhere, and then they had the sudden drop when the cryfish plague arrived associated with American cryfishes. And this was just a simplification just to end. That is not, of course, a simplification. It's like things like this relationship between invasive species and all other global change components or habitat modification features and so on. But Monse is saying that I should. And okay, thank you very much.